can do complex number arithmetic on the calculator. How? Well, right now, if I say square root -1, I get this error, non-real answers. And it says in real mode, all calculations must result in a real number. All right, I'll quit. Real mode. Let's take a look at the modes. So, normal, float, radian, function, thick, don't know what that is. Real. Oh, other than real, it gives us two options. A plus bi, re to something or other. I like a plus bi. Let's set our calculator in this mode and then see what happens if we enter the square root of -1. There we go. Notice now in the header it tells me that my mode is a plus bi. So I can use this for complex arithmetic, provided I can figure out how to enter an I. And looking over my keys, I find the proper key right at the bottom of the calculator. I see a tiny little blue italic I above the decimal point. That tells me if I hit second and then that decimal point key. Notice this blue is the same as the blue of the second key. That did indeed enter the number I on my calculator. So, if I say I squared, I should get, and indeed I do get, -1. Alright, this is pretty cool. I can use this to, for example, compute the result of this kind of complicated arithmetic. How? Well, I am going to remember to put the parentheses around each complex number. I've got 3 minus 5i plus 2 minus 3i times 6 plus 7i. And now I'm going to work out all the arithmetic in the numerator. That numerator works out to 36 minus 9i. And now I'm going to divide that by, what's my denominator? 2i plus 1. This gives it to me as a decimal. If I like fractions, I can tell it to convert to fractions. I get 3.6 minus 16.2i, or 18/5 minus 81/5 I. Notice I haven't told you how to do division with complex numbers yet, but I can tell you what it means, right? The sentence A divided by B equals C means the same as the sentence C times B equals A. So when I say that my 36 minus 9i over 2i plus 1 equals 3.6 minus 16.2i, what I'm claiming is 3.6 minus 16.2i times 2i plus 1 should give me 36 minus 9i. I can work out that arithmetic by hand to confirm that my calculator isn't just messing with me. 3.6 times 2i, that's going to be 7.2i. 3.6 times 1, that's going to be 3.6, minus 16.2i times 2i, that'll be 32.4i squared, minus 16.2i. I squared is -1, so this is plus 32.4. And combining like terms, I do indeed get 36 minus 9i. So that division on the calculator really does do what I think division should do, just in order to be division. So I'm going to have you try one of these just on the calculator. Compute 4 minus I cubed minus 2 plus I over 2 minus I. Pause the video and try this now. Alright, so I'm going to work out 4 minus I cubed, 4 minus I cubed. That's going to be 52 minus 47i minus 2 plus I over 2 minus I, 0.6 plus 0.8i. Now this last bit of subtraction I could probably do by hand, but if I don't want to, I can enter it as 52 minus 47i minus 0.6 plus 0.8i, and I get 51.4 minus 47.8i. And that's all there is to it.